Welcome to Callisto, a moon that captivates with its ancient surface. As one of Jupiter's largest moons, Callisto stands out with its distinct geological features and the possibility of a hidden subsurface ocean, making it a fascinating world to explore. Discovered on January 7, 1610 by Galileo Galilei, Callisto is one of the 4 Galilean moons, named after a nymph from Greek mythology. With a diameter of about 4,820 kilometers, Callisto orbits Jupiter at an average distance of approximately 1,882,700 kilometers, taking about 16.7 days to complete one orbit. Callisto is the 3rd largest moon in the solar system and nearly as large as Mercury. Callisto's surface is a striking record of the solar system's history, characterized by an abundance of impact craters. This heavily cratered landscape, one of the oldest in the solar system, provides a window into the past, preserving a timeline of cosmic collisions over billions of years. The moon's surface temperature averages around -139 degrees Celsius, though it can vary depending on location and sunlight exposure. Unlike its neighbor Ganymede, Callisto lacks a significant magnetic field, yet it harbors secrets of its own. Beneath its icy crust, scientists believe there may be a subsurface ocean, potentially containing more water than all of Earth's oceans combined. This ocean, if confirmed, would lie beneath a thick ice shell estimated to be about 100 to 150 kilometers thick, sparking intriguing questions about the potential for life. Callisto's composition is a mixture of water and rock. The surface is dominated by impact craters, some of which are surrounded by bright rays of ejected material. These craters are crucial for understanding Callisto's geological history and the processes that have. Among Callisto's most prominent features are its massive impact basins, such as Valhalla and Asgard. Valhalla, the largest of these, spans over 3,800 kilometers in diameter and is characterized by concentric rings formed by a colossal impact event. The exploration of Callisto has been greatly enhanced by spacecraft missions. NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided detailed images and data about Callisto's surface and internal composition. The Juno mission, currently studying Jupiter, has also contributed valuable information about Callisto's environment and its interaction with Jupiter's magnetosphere. Future missions to Callisto are on the horizon, including the European Space Agency's Jupiter Icy Moons Explorer, JUICE, which was launched on April 14, 2023. Taking 8 years to reach Jupiter, JUICE will conduct multiple flybys of Callisto, Ganymede, and Europa. Callisto's unique environment may also provide analogs for understanding exoplanets and their moons. By learning more about the processes that drive Callisto's geological activity and its interaction with Jupiter's magnetosphere, we can gain valuable insights into the dynamic. Welcome to Europa, one of the most intriguing moons in our solar system. Shrouded in an icy crust lies a world of mystery, a global ocean concealing more water than all of Earth's seas combined. Europa holds a wealth of wonders waiting to be discovered. This is more than just a moon. It's a gateway to understanding the vast possibilities of life beyond Earth. Europa, approximately 3,100 kilometers in diameter, orbits Jupiter every 3.5 days at a distance of about 670,000 kilometers. Its surface is a frozen wasteland, covered in ice with intricate patterns of cracks and ridges, hinting at a dynamic geological history. The average surface temperature of Europa is approximately -160 degrees Celsius. This temperature is extremely cold and remains relatively constant due to the Moon's lack of a significant atmosphere to distribute heat. Beneath this icy exterior lies Europa's most compelling feature, a subsurface ocean. Estimates suggest this ocean could be 60 to 150 kilometers deep, potentially harboring more than twice the liquid water found on Earth. This ocean remains liquid due to tidal heating generated by Jupiter's immense gravitational pull, creating a unique environment ripe for scientific exploration. It potentially harbors essential chemicals and energy sources necessary to sustain life as we understand it, raising profound questions about the existence of life beyond Earth. Recent observations hint at potential water plumes erupting from Europa's surface, suggesting periodic interactions between the Moon's interior and the space environment. These plumes could provide direct access to Europa's subsurface ocean, offering future missions a unique opportunity to search for signs of life without drilling through the thick ice. Exploring Europa has been a mission of fascination and discovery for decades. The Galileo spacecraft provided our first close-up views and fascinating whispers of Europa's potential as a habitable world. Now, NASA's Europa Clipper mission, scheduled to launch in October 2024, represents the next leap in our quest to understand this icy moon. Europa Clipper will conduct a detailed reconnaissance of Europa's icy shell and subsurface ocean. Equipped with advanced instruments, including ice-penetrating radar and cameras, the spacecraft aims to measure the thickness of Europa's ice crust, map its surface features in unprecedented detail, and analyze the composition of potential plumes erupting from the surface. The mission's objectives include determining the depth and salinity of Europa's ocean, assessing the habitability of this unique environment, and searching for evidence of recent or ongoing geological activity. These findings could provide crucial insights into Europa's potential to support life and inform future missions aiming to directly sample its subsurface ocean. Understanding the dynamics of Europa's ocean, its composition, depth, and interactions with its icy shell, could reveal fundamental processes that shape planetary bodies and their potential for harboring life. Insights gained from Europa could also inform our understanding of other icy moons in our solar system, such as Enceladus and Triton. Future missions may include concepts for landers or even submarines capable of exploring Europa's subsurface ocean directly. These missions could revolutionize our understanding of alien environments and provide a new perspective on the search for life beyond Earth. Welcome to Ganymede, a moon so unique that it defies all expectations. Larger than Mercury and boasting its own magnetic field, Ganymede is not just another moon orbiting Jupiter, it's a world of its own, full of mysteries waiting to be uncovered. Ganymede was discovered by Galileo Galilei on January 7, 1610, along with Io, Europa, and Kalisto. These moons are collectively known as the Galilean moons, named in honor of Galileo's pioneering observations. With a diameter of about 5,268 kilometers, Ganymede is larger than the planet Mercury, making it the largest moon in the solar system. It orbits Jupiter every 7.15 days at an average distance of approximately 1,070,400 kilometers. Despite its size, Ganymede's gravity is only about 1/7 that of Earth's. Ganymede's surface is a fascinating mix of two types of terrain: dark, ancient regions filled with impact craters and lighter, younger regions marked by grooves and ridges created by tectonic processes. These surface features are a testament to Ganymede's complex geological history. The average surface temperature of Ganymede is about -160 degrees Celsius, -256 degrees Fahrenheit. One of Ganymede's most remarkable features is its magnetic field, the only moon known to have one. This magnetic field interacts with Jupiter's massive magnetosphere, creating auroras near the moon's polar regions. These auroras are not only visually stunning, but also provide insights into the moon's internal structure and composition. Ganymede's icy surface covers a subsurface ocean, which might contain more water than all of Earth's oceans combined. This ocean lies beneath a thick ice crust, estimated to be about 150 kilometers thick. The presence of this ocean raises intriguing possibilities about the potential for life, making Ganymede a key target for future exploration. The surface of Ganymede is composed mainly of water ice and silicate rock. The icy surface is dotted with impact craters, some of which are surrounded by bright rays of ejected material. These craters provide a window into the moon's history, offering clues about the impacts and geological processes that have shaped it over billions of years. The exploration of Ganymede has been greatly enhanced by spacecraft missions. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided detailed images and data about Ganymede's surface and magnetic field. More recently, the Juno mission has been sending back data on Ganymede's magnetosphere and auroras, furthering our understanding of this giant moon. Future missions to Ganymede include the European Space Agency's JUICE, launched on April 14, 2023. Taking 8 years to reach Jupiter, JUICE will perform multiple flybys of Ganymede, Europa, and Callisto. It will deliver high-resolution images and detailed data on Ganymede's ice shell, subsurface ocean, and magnetosphere, greatly enhancing our understanding of its potential to support life. Understanding Ganymede's geology, magnetic field, and potential subsurface ocean is crucial for our broader comprehension of the formation and evolution of icy moons in the outer solar system. Insights gained from studying Ganymede could also inform our understanding of other icy bodies in our solar system and beyond, including the moons of Saturn and the dwarf planet Pluto. Welcome to Encelatus, one of Saturn's most captivating moons and a true gem in our solar system's icy crown. This distant world, enveloped in frost and teeming with mysteries, continues to enchant scientists and space enthusiasts with its remarkable features and intriguing secrets. Discovered on August 28, 1789, by the pioneering astronomer William Herschel, Encelatus is a celestial marvel that stands out among Saturn's many moons. Named after a giant from Greek mythology, this moon is not only notable for its size, but also for its extraordinary characteristics. With a diameter of about 500 kilometers, Encelatus is one of the smaller moons of Saturn, roughly 1/15 the size OD Earth. It orbits Saturn at an average distance of around 238,000 kilometers, completing a full orbit in just under 1.4 Earth days. Its orbit is nearly circular and lies in Saturn's equatorial plane, making it a key player in the planet's extensive ring system. Encelatus's surface is a stunningly smooth expanse of ice, punctuated by complex patterns and fissures. Despite its size, the moon is famous for its remarkable surface activity. Temperatures here can plummet to about -201 degrees Celsius, or -330 degrees Fahrenheit, keeping the water ice in a solid state and contributing to its dazzling appearance. One of Enceladus's most astonishing features is its plumes, jets of water vapor, icy particles, and organic compounds erupting from the Moon's southern polar region. Detected by NASA's Cassini spacecraft, these plumes point to a subsurface ocean beneath Enceladus's icy crust. This ocean, interacting with the rocky core, could create a chemically active environment potentially suitable for life. The presence of organic compounds and salts in the plumes suggests conditions that might support microbial or even multicellular life. Analyzing these materials provides vital clues about the ocean's composition and habitability. Consequently, Enceladus stands out as a leading candidate in the search for extraterrestrial life. Enceladus's icy surface is also home to a variety of geological features. The Moon's surface is marked by smooth plains, ridges, and fissures, alongside the prominent tiger stripes, long parallel fractures that vent the plumes. These features hint at a dynamic interior, with tidal forces from Saturn playing a significant role in shaping the Moon's geology. Cassini's flybys provided humanity with its first detailed look at Enceladus, offering invaluable insights into its geysers, icy crust, and potential subsurface ocean. The mission revealed that Encelatus is not just a frozen world, but a geologically active moon with intriguing possibilities for astrobiology. Exploring Enceladus offers a unique window into the outer reaches of our solar system, where icy moons and distant planets challenge our understanding of planetary science and the potential for life. By studying Encelatus, we not only seek to unlock the mysteries of this fascinating moon, but also gain insights into the dynamics of icy worlds and their place in the cosmos. Welcome to the red realm of Mars, where two small, enigmatic moons orbit the fourth planet from the Sun. These celestial companions, Phobos and Deimos, may be diminutive in size, but they hold a wealth of mystery and intrigue that continues to captivate scientists and space enthusiasts alike. Phobos and Deimos were discovered by American astronomer Asaph Hall on August 12th and August 18th, 1877. Named after the mythological sons of Ares, the Greek god of war, these small moons play a crucial role in our ongoing efforts to understand the Martian system. Phobos, the larger of the two moons, has a diameter of about 22 kilometers, while Deimos is slightly smaller at around 12 kilometers across. Here's a comparison of Phobos, Deimos, and our moon. You can see how small Phobos and Deimos are next to our moon. Phobos orbits Mars at an average distance of just 6,000 kilometers, making it one of the closest moons to its parent planet in the entire solar system. Deimos, on the other hand, orbits at a greater distance of about 20,000 kilometers. Phobos completes an orbit around Mars in just under 7.7 hours, making it the fastest orbiting moon known, while Deimos takes about 30.3 hours to complete its orbit. Both moons have irregular shapes and are covered in a thick layer of dust and debris, giving them a rugged appearance. Phobos' surface is scarred by numerous grooves and large craters, including the enormous Stickney crater, which is a dominant feature on the moon's surface. Deimos, in contrast, has a smoother appearance with fewer prominent craters. One of the most intriguing aspects of Phobos is its rapid orbital decay. Due to tidal forces exerted by Mars, Phobos is gradually spiraling inward, nearing the planet at a rate of 6 feet, 1.8 meters, every 100 years. At this rate, The Moon is on a collision course with Mars and will either crash into the planet or break apart into a ring system in about 50 million years. Deimos, while more stable in its orbit, exhibits interesting features as well. Its surface is covered with a layer of fine dust, which has led to a smoother appearance compared to Phobos. The low gravity on Deimos allows for a unique landscape, with the potential for interesting geological studies if future missions visit this moon. Both Phobos and Deimos are thought to be captured asteroids or remnants of larger bodies, giving them a different origin story compared to many other moons in our solar system. Their composition, primarily made up of carbon-rich rock and ice, contributes to their dark, reflective surfaces. Our knowledge of Phobos and Deimos has been shaped by several key missions. Mariner 9, arriving to Mars in 1971, was the first to capture close-up images of these moons. Fun fact about Mariner 9, its final transmission was on October 27, 1972, and its exact fate is still unknown. It might still be orbiting Mars, or it could have burned up or crashed on the surface. While there are no scheduled missions for Phobos and Deimos, future Mars explorations could reveal more about these moons and their role in the Martian system. If you found our exploration of Phobos and Deimos as fascinating as we did, welcome to Triton, Neptune's largest moon and one of the most intriguing and enigmatic objects in our solar system. This distant world, cloaked in icy frost and shrouded in mystery, captivates scientists and space enthusiasts alike with its unique features and tantalizing secrets. Discovered on October 10, 1846, by the American astronomer William Lassell, named after the Greek god of the sea, Triton, this moon stands out not only for its size, but also for its distinctive characteristics among Neptune's retinue of moons. Measuring about 2,700 kilometers in diameter, making it slightly smaller than our own moon. It orbits Neptune at an average distance of roughly 355,000 kilometers, completing a full orbit around the planet every 5.8 Earth days. Its retrograde orbit, moving in the opposite direction of Neptune's rotation, suggests that Triton might have been captured by Neptune's gravity rather than forming alongside it. Triton's atmosphere, though extremely thin compared to Earth's, is fascinating in its composition. It consists primarily of nitrogen with traces of methane, giving the moon a faint, wispy haze. This thin atmosphere, combined with Triton's frigid temperatures, creates an environment where surface conditions are extreme. Temperatures can plummet to around -235 degrees Celsius or -391 degrees Fahrenheit. One of Triton's most remarkable features is its surface, which presents a diverse and striking landscape. The moon's icy crust is marked by vast plains of frozen nitrogen, rugged mountain ranges, and intriguing dark streaks. Perhaps most astonishing are the geysers that shoot nitrogen gas and icy particles high into space. These geysers, first observed by NASA's Voyager 2 spacecraft in 1989, indicate that Triton has internal heat sources, possibly from tidal forces or radioactive decay, which contribute to its geological activity. These geysers suggest that Triton is not just a passive icy world, but a geologically active one. They erupt from fissures in the crust, and the material ejected forms transient plumes that can reach heights of hundreds of kilometers. This activity hints at a subsurface ocean or an interior layer of liquid water beneath the icy crust, potentially warmed by tidal forces or residual heat. Voyager 2's flyby in 1989 remains the only close-up observation of Triton to date. offering humanity its first detailed views of this distant moon. The spacecraft's instruments provided key data on Triton's geysers, icy surface, and atmospheric composition. The mission revealed that Triton's surface is not as uniform as once thought, but is instead characterized by a complex interplay of ice, frost, and volatile compounds. Exploring Triton offers a unique window into the outer reaches of our solar system, where icy moons and distant planets challenge our understanding of planetary science and the potential for life. By studying Triton, we not only seek to unlock the mysteries of this enigmatic moon, but also to gain insights into the broader dynamics of icy worlds and their place in the cosmos. Welcome to Titan, Saturn's largest moon and one of the most intriguing bodies in our solar system. With its thick atmosphere and diverse landscape, Titan presents a world shrouded in mystery and ripe for exploration. Discovered on March 25, 1655, by the Dutch astronomer Christian Huygens, Titan stands out as the only moon in our solar system with a substantial atmosphere. Named after the Titans of Greek mythology, with a diameter of about 5,150 kilometers, Titan is larger than the planet Mercury, making it the second largest moon in the solar system, just behind Jupiter's Ganymede. Titan orbits Saturn at an average distance of 1,222,000 kilometers, completing one orbit every 16 Earth days. Titan's atmosphere is a thick, hazy blanket composed mainly of nitrogen, with traces of methane and other hydrocarbons. This dense atmosphere, which is 1.5 times thicker than Earth's, gives rise to weather systems that are surprisingly Earth-like, including rain, wind, and seasonal changes, though the rain here is not water but liquid methane. The surface temperature hovers around a frigid minus 179 degrees Celsius or minus 290 degrees Fahrenheit, cold enough for methane to exist as a liquid. The surface of Titan is a complex and varied landscape, featuring vast sand dunes, lakes, rivers, and seas, again, not of water but of liquid methane and ethane. These hydrocarbon lakes and seas are primarily found near the polar regions and are the only large bodies of liquid known to exist on the surface of any body other than Earth. Titan's largest sea, Kraken Mare, spans over 1,000 kilometers in length, offering a tantalizing glimpse into the alien hydrology of this distant moon. Beneath Titan's icy crust, scientists believe there may be a subsurface ocean of water mixed with ammonia, potentially providing conditions suitable for life as we know it. This hidden ocean, shielded by a thick ice shell, adds another layer of intrigue to this already fascinating world. Titan's geological features are shaped by a combination of icy volcanism, tectonics, and erosion, driven by its unique atmospheric and surface processes. The interaction between Titan's surface and its dense atmosphere has created a dynamic environment where organic molecules are formed, hinting at complex chemical processes that could have implications for the origins of life. NASA's Cassini spacecraft, which orbited Saturn from 2004 to 2017, provided unprecedented insights into Titan's surface and atmosphere. Cassini's radar mapped the moon's surface in detail, revealing its lakes, dunes, and mountains. The Huygens probe, deployed by Cassini in 2005, made history as the first, and so far only, probe to land on Titan's surface, transmitting images and data from this alien world back to Earth. Looking to the future, NASA's Dragonfly is expected to launch in July 2028 and to take 6 years to reach Titan, arriving by 2034. This innovative rotorcraft will fly across Titan's diverse terrains, sampling its atmosphere and surface, and searching for prebiotic chemical processes and potential biosignatures. Titan's unique characteristics make it a prime target for future exploration, and the lessons we learn here may one day help us unlock the secrets of exoplanets and their moons. By studying Titan, we not only expand our knowledge of the solar system, but also push the boundaries of our understanding of life's potential in the universe. Welcome to Io, one of the most fascinating moons in our solar system. Unlike any other celestial body, Io is a volcanic powerhouse, a fiery world sculpted by intense geologic activity. Io's surface is a vibrant mosaic of erupting volcanoes, flowing lava, and sulfur deposits, making it one of the most intriguing moons for scientific exploration. It was discovered on January 7, 1610, by Galileo Galilei, along with Europa, Ganymede, and Callisto. These moons are collectively known as the Galilean moons in honor of Galileo. Io, roughly 3,642 kilometers in diameter, orbits Jupiter every 1.77 days at an average distance of about 421,700 kilometers. Its surface is a dynamic landscape of volcanic plains, towering mountains, and vast lava lakes, a testament to the moon's restless interior. The average surface temperature of Io is approximately -143 degrees Celsius, which is equivalent to -226 degrees Fahrenheit. However, Io's surface temperatures vary greatly due to intense volcanic activity, with some hot spots reaching up to 1,600 degrees Celsius. Io's defining feature is its extreme volcanic activity. It is the most volcanically active body in the solar system, with over 400 active volcanoes, some erupting fountains of lava dozens of kilometers high. The largest and most famous of Io's volcanoes is Loki Patera, a volcanic depression 200 kilometers in diameter. Loki Patera is a lava lake that periodically overturns, causing massive eruptions. Another notable volcano is Pele, which has a plume that rises up to 300 kilometers above the surface. Io's mountains are notable, formed by volcanic processes and intense gravitational interactions, unlike Earth's tectonic mountains. Some peaks reach up to 17.5 kilometers, double the height of Mount Everest. Recent observations reveal that Io's volcanic eruptions are not just impressive in size, but also in diversity. Some eruptions produce massive lava flows that can cover hundreds of square kilometers, while others generate towering plumes of volcanic gas and dust that rise high into space. These plumes can be so powerful that they create temporary atmospheres around Io. Io's atmosphere is extremely thin, composed primarily of sulfur dioxide. It is constantly replenished by volcanic activity and is in a delicate balance with the moon's surface and Jupiter's magnetosphere. The interaction between Io's atmosphere and Jupiter's magnetic field creates intense auroras. Exploring Io has been a mission of fascination and discovery for decades. The Galileo spacecraft provided our first detailed views of Io's tumultuous surface. It revealed the complexity and diversity of Io's volcanic activity, showing us a world that is both alien and dynamic. Now, the upcoming mission NASA's Europa Clipper, although primarily focused on Europa, will also provide valuable insights into Io's volcanic activity through its flybys. A proposed mission concept, the Io Volcano Observer, IVO, aims to conduct multiple flybys of Io, capturing high-resolution images and thermal data and studying the Moon's magnetic field. This mission could provide unprecedented insights into Io's volcanic processes, surface composition, and internal structure. The study of Io's extreme environment can also provide analogs for understanding exoplanets and their moons. By learning more about the processes that drive Io's volcanic activity, we can gain insights into the geologic and atmospheric dynamics of other celestial bodies. Io, a world of fire and brimstone, holds secrets that challenge our understanding of geologic activity and planetary science. From its constantly reshaped surface to its powerful volcanic eruptions, this moon beckons us to explore its fiery depths. Exploring Io's volcanic wonders is just the beginning. If you enjoyed this video, consider liking it and subscribing for more space exploration updates. Have questions or thoughts? Drop them in the comments below. We'd love to hear from you. Stay informed, stay curious. Thank you for watching.